Okay, this is a simple form. One more system commonly used, point fixed glazing, but it will be a small part. Sometime people tend to use they want to see only glass. Of course, you can use, they call it point fixed glazing or spider glazing. I don't touch here with this brief because it got lot of varieties. Now let's start going in depth. So we have seen facade, it's how it got evolved, how the thing started going forward, and choice of material, different kinds of material, then how you design a system, what are the different systems available, and then we went in depth to understand how a unitized system is done, why a unitized system. So now we are going to touch base on various material. So for this again I am taking a system of whatever semi or unitized system as an example, but primarily focusing on aluminum based system, because that is what, with that only the facades are done mostly. Some places they use steel, but it is not wisely used and it is not advisable as well. So a simple system, a good system, if you want to design, then use aluminum as a base for facade. So aluminum, let's touch base. It started during 1886 after testing various material which qualifies to require for aluminum as a good material. Or it's from bauxite, it can be extracted and it's good for the next 300 years. So we have a material which got 20 to 30% of aluminum inside. So it is abundant, but however 300 years will maybe for next week to, I don't know when they said this 300, but it will be exhausted soon, not so soon during our lifetime, maybe another 100-150 years. So aluminum is a versatile material which can be used as a structural element to design a facade. So today buildings are designed to tackle, as we saw before, all this movement, impacts of nature, commercially viable, thermal expansions. Aluminum qualifies to all this. Any other material, example you use any other metal, they will become expensive and not malleable. It is very hard to work with them. So aluminum became a cost effective solution for people to consider using it as a facade element because of the nature. If you see a little bit briefing about aluminum, it is excellent and it does not corrode, and it is strong. If you even look at the aircraft, they use a lot of aluminum. So aluminum plays a major role in designing. It can be extruded, it can be done for any shape what you like to be extruded, but at the same time it is excellent for heat. When I say heat, of course you can't expose it, it transmits heat, but it expands well and contracts well if you design it properly. So aluminum being a material, it works well, formability, cold workability, it is excellent, and anodizing and means surface protection against corrosion. So it works very well compared to any other metal. Like the next metal available is steel, copper, it is not too strong. So strength wise, malleability, function, aluminum plays a major role. So it can be done in any form. As I said, it can be extruded, it can be casted, but aluminum is there for us to use as an element. In general, surface protection. Now we are talking about how you protect the surface of aluminum. Yes, we have a choice of aluminum to use as a material, but you have to protect them. There are various forms of protection available. First thing is you do an anodic process, you call it anodizing. What you do, you take the material, you dip it in an anodic solution to change the surface of aluminum by making it more stronger in form of, you make a coating in form of structure change to the system. So the surface of aluminum will get an anodic process by means of dipping it into solution and electrolyte process, where it will seal the surface. So you get a natural change of skin condition. If I say it's just like, applying cream for your face, but that is called a coating. But toning your skin, the skin color is changing by means of toning it, it's just like anodic process. So, aluminum is toning up. So, it makes it more friendly, and you get a natural color. The color also can be changed nowadays, they do various colors also by adding some advanced systems to it, but it's good because you are changing the material, you are not depositing anything, you are changing the aluminum surface by anodic process, hence it acts as a protective coating. So, what it does, it protects and seals against any form of rust or anything, or surface rusting or pitting, whatever can happen with the environment impact. Again, it is harder because it's not a coating, because it's a surface change. PVDF, it's a form of like a car paint, right? You can paint it by spray painting the system as well. So, there are different, you can read through the things. The systems call for different colors. There are advanced systems available. PVDF is good for the external conditions where you have a lot of corrosion happening, or building facing sea front. So, there are plus and minus. So, anodic, yes, it's harder, but there is no fixation. You have a scratch or a dent, you can repair it. Okay, there is no touch-up work available unless you just do some superficial thing. But when you go for PVDF, it's like it's a coating, like what we do like makeup. So, you apply a paint that is fixable. Even if you have a dent or a scratch, you putty it, you repair like how you do with a car with the proper quality control in place. And you got variety of colors. You can do million colors, with PVDF. So, there's a pros and cons and advance of systems. At the same time, when we are choosing the coating system, you have to be very careful. What surface protection I am going to give? Why? It is not for funfair. You can use, say, example, I don't want to put a PVDF on the internal of the building. It's not only expensive, but it doesn't help. Why I have to spend so much money on doing a PVDF? Rather, I do some other coating like a powder coating. So, there are a lot of different varieties of system available, but there are three common ones, which are anodizing, powder coating, and PVDF. So, anodizing is changing the material hardness by improving the surface in form of anodic process. Powder and PVDF, they are a deposit. It means something you deposit on top of the mullion like paint. So, PVDF and its advantages, as I said, it can be fixed easily. If there is scratches, dents, whatever, you can repair. So, we saw aluminum as a material. So, when you go back to see aluminum, it's just not simply you take an aluminum and you can use it. If you see here, there is a code, right? What they do here is, they go and temper the aluminum. They go to make it stronger. See, when aluminum comes out of extrusion, the extrusion comes out of your dye process, or the extrusion process, they are like soft like sponge, you can crush it. So, what you do, you go and temper it, you make it stronger by putting it in an oven, you heat it to the temperature where it can be made to your requirement. Like commonly what is being used for our industry is T6, which is a tempered alloy, where you still can work around it. So, depends on the choice. If I need something little bit flexible where it has to expand more like cappings or something, then yes, I can reduce it to T5 or T4, but that's how you decide. So, aluminum goes through the process. Of course, you saw what is the surface protection available. So, by applying the process of paint or anything, you take care of the surface against corrosion, against pitting, against damages with weather. So, next, what is the thing? Glass. Glass is a good invention. Of course, in the previous sectors, I believe they were spoken a lot about glass. I would like to touch very briefly here. Glass is an element, it is a good invention which brought us to the nature closer. Imagine you are sitting against a bare wall. You don't have any life. You don't communicate to the outside world. You don't know what's happening outside. You don't know whether it's sun, rain, whatever. Only If you hear something, then you know. But glass changed that paradigm. What it did, it acts as a sheet of whatever form they put in. It communicates with the outside world. It lets you to communicate. It lets you to see through. So that invention is brought to the facade, and it is playing a major role today. And there are a lot of factors while choosing a glass that will be briefed by our colleagues in the next classes. So mainly this is how we do. When you choose a glass, okay, you go and temper them or anneal glass, whatever. You can put a float glass, briefly. Depends on your requirement. Or you heat strengthen your glass, depends on the requirement by the structural engineer, or you temper the glass. So these are all few things to harden it, like when we see an aluminum T3, T4, T5, T6, it depends on the building requirement and what you are designing for. So glass also same, whether I want a heat strengthened glass or a tempered or a float glass, depends on the structural requirement by the engineers. Now we talk about anchoring system. I didn't go in depth to talk about different anchors. I am taking a simple anchor. I believe construction industry widely uses a commonly used anchor. So you drill a hole and you just put this impact anchor at site and you tight it. That's all. This is the commonly used system available, and it comes in various material as well as in stainless steel. You can do it with galvanized. It depends on the choice of the substrate. So the anchor bolt, what it does, it carries the load back to the structure. So you had a bracket, you have a system. Now how you connect them together is through this anchoring. So you anchor your system to the mother structure. Sometimes you can bolt it if it is steel. If it is concrete, then yes, of course you need to get an impact anchor, or you can use a cast-in channel, or you can use a cast-in plate. Various anchoring system available, but what commonly used system is just simple. What you see over here, it's an impact anchor. You drill a hole onto the structure. You just hammer this and put your bracket and you tight it. It expands inside. Whatever you see here in this portion. The structure line is until here, and then when you tighten it, it expands like this, what you see here. So whatever it is here, these are the brackets, what you see, how they get fixed. So this anchor bolt is the main thing which governs the whole system. So you bring the system and then you drive the anchor through this. Of course, you have certain factors to consider, how you control them based on the calculation. The engineers will be doing it. There are limitations, of course. You can't do it too much towards the edge of the concrete. Here, what you see is anchoring to a concrete. So similarly, here the whole system gets connected via these bolts. So you can see here. Here, what you see is with the channel. What you saw before, it's attached to a cast-in channel. If the channel is not there, you can do away with the anchor bolt. What it does, it transfers the live and dead loads to the structure, to your mother slab or mother structure. So you bring the facade and you attach it to your mother slab. So these anchor bolts or channels, where you tie them, they transfers the load, and then they connect the curtain wall to your main building. This is what these anchors do. Okay. In the system, now we are going a little bit more deeper to understand the system. We understood about aluminum, what aluminum does and how friendly it is to use for curtain wall. We saw glass very briefly because that will be covered in depth in your other courses. So glass is a good material for communication, but not limited. We saw in the beginning, you can use anything. Not only glass, you can put stone, you can put ceramic tile, you can put paper board, you can put copper, you can put gold, whatever it is. So material choice is yours. But what we see now is briefly what commonly they use in the system. Now we talk about gaskets. What gasket does? What is a gasket? See, any material, when you put them together, there is an abrasion and you have to separate them. If you don't separate metal to metal, what will happen? They will start making noise. They will start binding together. They will sometime, if excess heat is there, they will go automatically to go and merge well together. So, we have to separate them, we have to keep them separate. At the same time, taking care of little bit of expansion and contraction in different direction. So, a good material available is called EPDM, ethylene propylene diene monomer, or neoprene or silicone or elastomer. So, it is a kind of special rubber which takes care of this function, which acts as a seal, but at the same time it expands and contracts with the system and it wedges through, like what you see over here. These gaskets are used as a wedge and this is the glass. So, there are two gaskets in the system which wedges them together, it means they keep them together, but at the same time it will allow the system to move. So, if there is something happening with the movement, the glass can move, but it keeps under the friction. So, different types of gaskets are available. People have to understand and design what is the requirement, where I have to put the gasket. So, these are the properties. If you run through, you will see EPDM, and again choice of gasket and its hardness depends on your requirement. It is not something you just get it off shelf and put it up. So, you design it, you understand what is the strength I need, whether it has to be too flexible or I want it harder. So, you increase the hardness of the rubber. When I say rubber, it is EPDM or silicone or whatever material you have. So, the choice of elasticity you choose. These are the factors. If you see here, elongation, how long you want to elongate, when you want that to break, what is the hardness you need. You can't put a too hard gasket into a cavity where there is lot of expansion, then if there is a glass against it, the glass will tend to break. So, you need to have a flexibility as well. So, designing a gasket plays a very key important factor in the system. Like example, if you see here, there is a mullion which moves. You see that black color thing here, what you see over? This is a gasket. So, here what it does, it acts as a thermal barrier as well as material contact, because there are two aluminum. This is a aluminum mullion, split mullion, and there is a leg. If you do not have a gasket here, what will happen? There is a thermal bridge plus metal to metal contact, it is worst. So, you keep the gasket as a barrier. What it does? It splits. Again same time, these are the joint where air can go through or heat can go through. So, your rubber is a good conductor. It means it does not conduct heat inside, it is a barrier. So, you create more gaskets here, do not let any heat or air or water to go through. So, gaskets play a very important role in your design. It not only acts as a separator, but it controls air, water through the joints, and also to create expansion in the system. It prevents from thermal cracks. Now, we are going a little bit more to understand about the system. Yes, we saw about gaskets and how they work. Now, we are going to see how the bonding of glass takes place in this advanced system. We saw a stick system where they mechanically held the glass. Then in semi-unitized and unitized, they found a way to glue the glass to the frame or glue anything material to the main grid. So, how you do that? So, the process starts with this. So, before even they can glue, they have to understand the requirement. There are a lot of requirements there, structurally as well as with weather, with all the other factors. So, you need a system where you can bond the material to your main frame. So, I have a grid of aluminum created, we saw, but I need something which to keep them together. Mechanically, yes, we can hold them together like what you see here. See example, what you see here, this is mechanically held, there is no gluing. So, they have a gasket, a wedge gasket, then you have a glass, and then they have a mechanical system which compresses on both sides. So, your glass is held mechanically, not glued on, but you can't keep on doing this, mechanically fixing them at site and keep doing. So, the invention went in to find a system which can glue. So, to create that, yes, if you see here, this is what they call a structural sealant. We will see them in the next few slides. So, this is the glue they use to glue the glass or any other material to your main system, what you see here. To get this sealant there, you need a space. It is a flowable glue where you pump through a nozzle, so it goes in. So, for that, yes, there is a way you calculate how much of sealant need to be there to hold this glass via calculation, but to create that cavity or to create that space, first thing you need is a double side tape. What is a double side tape? A tape, a foam which got glue on both sides, that is all, simple. You put this tape in this place and then you glue the glass, so that the space you created for the glue. So, you create a space required for the sealant to travel. So, you put the double side tape and then you glue the glass to the frame, temporarily you hold it there. Then what happens? You are ready to apply a sealant. The sealant is here, what you see. So, you have to pump this through a joint, whatever detail you have done, but this double side tape is very crucial because it keeps the glass away from the frame, so that the required sealant can be pumped through the joint. So, double side tape is important as well, just we are putting into the system. Then a different topic altogether, but here also when you start looking at building, there are a lot of factors involved. One of the major factor, okay, we spoke about factors affecting from external. So, wind, water, whatever comes out, heat. So, you design a system which takes care of all those. But now, what will happen if there is a fire inside the system, inside the building? So, you cannot put the whole building at risk. So, you have to design a system which can contain the fire within the floor space or within the room space, so that the fire can be contained easily. If there is a spread, then the whole building will go for a toss. However, glass, there are different glasses available today to take care of fire, not to spread, but they are very expensive. But commonly used glass, they do not stand even for 5-10 minutes, they will break. So, hence letting the fire to keep bridging. So, in this image, if you start to see, they have systems available to stop the fire spreading to floor to floor. So, it means what will happen? There is a curtain wall, what you saw in the previous slides. I will go back there to show to you. Okay, example here. So, you have a curtain wall attached, and now you see here what happened. There is a gap between these two, sometime 50, sometime 100, whatever. So, this gap is through gap from the floor below. So, you have to seal the gap by means of a fire stop or a smoke seal. Commonly in all the buildings, you do not use a fire stop because your system is not fire rated. Unless your system is fire rated, there are hourly fire rated systems like 1 hour, 2 hour, 3 hour, whatever. But in any common building, you see, mainly they use non-fire rated wall, i.e. your wall cannot withstand any rating. So, either they are half an hour or less or even 5 minutes. So, your system, what you are going to do between the slab, you should call that first a smoke seal. When smoke seal means, first you should prevent the neighbors or the people above the floor or below the floor not to get suffocated. Second, you have to make sure the smoke is contained within the floor below, not to get spread. So, you seal the joint by means of non-combustible material, so which is called a fire stop insulation. Even you do not let the fire to spread. So, you can call this as a fire stop, but your prime important thing over there have to be for smoke, because the first killer in a fire is smoke. If there is a fire, lot of people get injured first with the smoke. They can't inhale, and then they get disease, and the worst thing happens. So, smoke is the first thing you have to take care, then fire. So, fire spread and smoke seal have to be contained within the floor. Hence, the fire stop and design of fire stop is very crucial between floor to floor or between wall or between adjacent rooms. So, the design have to take care of all those things, and these are the material available. They have mineral wool, they have rock wool. They are all made of non-combustible material. So they use that and treat the joints properly with the proper design. So when you design a system, these are all the factors you have to take care. It is not just simply going on. So now you see this gap here, whatever I shown in this previous video. So there is a gap between the wall and the mother slab or mother building. So this gap is now filled with the fire insulation, fire stop insulation or smoke, whatever we call it. So the insulation takes care of this fire spread. It means you have a compacted system inside. It's compressed within the floor cap with a tray or some other system. So the smoke doesn't go from below. And the fire spread also, as being a non-combustible material, it doesn't let the fire to spread to the next floor. So it is both together. And then you also can see one more insulation here. This we call a spandrel zone. It means a spandrel, you create a spandrel at the floor level to hide the structure behind, or you create that as a standard system where you don't let the fire to spread between floor to floor. So your spandrel design plays also a key role while you are designing a facade. You can't just simply say, okay, I want to put glass all the way. Yeah, glass, it breaks unless you have a fire rated glass. The normal glass will break. When there is fire, immediately it will break. So it is advisable always. See, normally a fire spread takes up to 1.2 meter, when it goes from floor above to floor below. So the common practice is to have a good spandrel zone insulated, so the fire takes time to spread to the next floor. So it gets contained. The idea of all these fire stop, smoke seal, the insulation, they should contain the fire within the floor where the fire happens. And not only that, of course, this insulation also plays a big role in form of thermal. So when the glass class was going on, there they will talk to you about more about thermal and comfort and so on and so forth. They also play a major role, because being non-combustible, they are also good in servicing heat. It means they don't get a heat to travel through them, because it's a non-combustible and a non-transferable material. It doesn't transfer heat. So it's a good heat retardant as well. So your smoke seal plays, fire stop plays a crucial role in your design, and it has to be done properly. Otherwise, in case of eventual accident of floor below, the whole building will be going for a toss. These are various examples of fire stop, how they do with slab, and then they seal it with rock wool, mineral wool. So this is the systems available for them, depends on the detailing required by architect and client. You design your fire stop system. This is openable windows, how you attach them. There are hardwares available. I don't want to go in depth because it's a big subject on its own, but you create openings. Why you create a opening in a wall? If you have a complete wall, of course, if anything happens internally, like AC is not working, you can make some openings on the wall, so you let fresh air to come in. But there are theories available in this part of the world, which personally I don't think it is right. In most of the buildings, you see, they provide a lot of openable windows. They don't work. First of all, when you ask them why you are providing, well, because for fire. I don't understand the relationship between fire and openables. However, it's a debate going on for years. So openable helps you to get more air inside from outside. So creating openable in the facade, yes, there are a lot of hardwares available to attach them to your wall. So there is a design. When you design them, you have to take care of those elements. Now we will go in depth to understand each and every single material, what they do, how they help. As already we have seen, but we will go down in depth to see them. Those are all things, we put them together. See, to make one system, one curtain wall, how many 16 of things are available? These are the factors. You look into when you are starting to design aluminium frames, curtain wall section, gasket, seal and glass, brackets, vent panel, backer rod, foam, fasteners, insulation. So there is a checklist. You keep doing.